Okay, let's give you guys some more practice. So find the limit of this sequence as n tends to infinity. So press pause and have a go. Okay, so to do this, the idea here is to trap this limit in between two things. To trap it in between two things, and then use the squeeze theorem to find the limit of this. So let's just try and trap this bit here. So let's just look at this bit. So let's just look at this bit here. So if you look at this here, you're taking the nth root of this bubble here. So if you're going to take the nth root of this bubble here, you see if you make this bubble smaller by just removing this one here, then because this bubble here is smaller, then when you take the nth root, it must be smaller than the original. Because if you compare this bubble here with this bubble here, this bubble here is smaller than this one here because you're omitting the one. So because this bubble is smaller, when you take the nth root, it must be smaller than the whole thing here. So you know that this thing here, must be bigger or equal to 3 to the power of n. 3 to the power of n, and then you take the nth root of it. And then if you look at this bubble here, hang on, you're taking the nth root. So let's look at the bubble here. If you can make this bubble bigger than this bubble here, then this whole thing will always be bigger or equal to this thing here. If you can make the bubble here bigger than this bubble here. Well, if you look at this, you can always make it bigger by doing this, plus 3 over n. Because if you look at the graph of 3 to the power of n, when it's 0 is 1, and if you well this thing here will always be bigger or equal will always be bigger or equal to 1. So 1 looks like this. So this is a graph of y equals 1. So this here is a graph of 3 to the power of n. So as you increase n, as n gets bigger and bigger, you can see that this thing here will always be bigger than y equals 1. So the point here is that this thing will always be bigger than this. So you can trap this in between two things. You can trap it in between hang on, bear with me. You can trap it in between two things. So you can trap it. So this would be 3 to the n, taking the nth root, and then this thing here will be the nth root, 3 to the power of n plus 3 to the power of n. Because if you look at this bubble here, compare this bubble with this bubble here will always be bigger or equal to this one here. So the overall thing must be bigger than this. Well, look at this thing here. You can imagine this as 3 to the power of n, and then when you take the nth root, it would be like this. So now this times this, that would be 3 to the power of n over n, which is 3 to the power of 1. So this thing here is just 3. So this thing here is just 3. So now if you look at this bit here you've got exactly the same thing plus exactly the same thing. That means you've got two lots of the exactly the same thing. And then the nth root, visualize it as this. So now you can imagine this as being like one block here and one block here. Imagine it as to be a 1 there. So this times the power here, that will give you that. That will then give you 1 over n. And then this times this n here, so that will be 3 to the power of n over n. Well, 3 to the power of n over n is 1, which is just 3 here, which is this 3 here. And then this is you taking the nth root of 2. So now you can see that this thing is always trapped in between this and this. So now take the limit of all three. So now take the limit of all three. Take the limit as n tends to infinity. Take the limit as n tends to infinity. Take the limit as n tends to infinity. This here is a constant, so take it out. So that's your 3. This is your limit here, and this is your whatever here. So now if you look at this here, the limit of this is going to be 3. It's a constant because y equals 3. Well, as n tends to infinity, it will be 3. So this thing here will be 3. This thing here, remember that anything to the power of 0, let's say 7 to the power of 0 is 1, 5 to the power of 0 is 1, 2 to the power of 0 is 1. But then as n tends to infinity, 1 over n is going to head towards 0. So this is like, well, this thing here is heading towards 1. This whole block here, as n tends to infinity, this whole block here will be 1. So you've got 3 times 1, so that will be 3. So so now this thing here, which we don't know, it's always trapped in between here, in between 3 and 3. So by using the squeeze theorem, we can say that the limit of this thing here is 3. Okay. So next one. So find the limit of this as n tends to infinity. So press pause and have a go. Okay. So to do this, if you look at this here, sine n. Well, if you look at sine is always trapped between 1 and -1. So you can say that sine n over n is so the biggest that this thing here could be is 1, and then over n here. The smallest thing that this could be is -1. So you can trap it in between this. So now take the limit of all three. So this as this thing here heads towards infinity, 1 over a very, very big number. This bit here is going to be 0. This bit here is going to be 0. This thing here is going to be 0. So therefore the limit of this as n tends to infinity will be 0. So the point here is that this thing here is as n tends to infinity, this thing here is going to head towards 0. And then looking at this here, so here as n tends to infinity, this here is going to become very, very big, 1 over very, very big. For example, this, and then that makes this whole thing here to be 0, heading towards 0. So it's like you doing cos of 0, which will be 1. So the limit of this will be, well, this is going to be 1, and then this here is going to be 0. So the limit will head towards 1. Okay.